Blueglow Electronics. This will be our third in the series of videos on this Marantz 2250B. The first video was kind of showing a little bit of what was wrong with it. Had to order some parts, so we had a second video where I actually got the parts in and repaired the unit, but got ready to do the bias on it, and I thought, you know what, I want to make a separate video on just how to bias this unit. Very short video. We'll show you how to bias Marantz 2250, and if you can learn that, you can bias just about any Marantz unit out there. So the 2250 is no different than doing the 2270, 2275, 2230, 1060, 1030, etc., 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 etc. I'm going to swing over and show you the instructions, and then we'll come back around to the unit itself. Alright, hope you can see this. So what I did was I downloaded the service manual for the 2250B. So it's a fairly long document. We're on page 7 of 42. If you'll notice here at the very top, it's just the Marantz service manual. So if we kind of go back down to page 7 and get us back down here to the audio adjustment section. So let's read this. Voltage adjustment. Connect a DC voltmeter between pin terminal 804 and 805 and adjust the trimming resistor R806 for 35 volts DC. So if you'll notice down on page 11 of the service manual here, it shows a top-down view of the unit, and P800, this little section right here, is the power supply unit for the Marantz. It's both the power supply and the speaker terminal protection circuit here. It's easy to identify. You'll see a relay. It's about the only spot in the Marantz unit you will find a relay. Alright, so if you will scroll on down then to page, looks like 20, what you'll see here is up top first you'll see the power supply schematic, board P800. And then if you'll notice here, you have the power supply actual board layouts. This is kind of a logical diagram of how everything works. This is a physical diagram of how it was worked out, laid out. But if you remember, it said jumper 804 and 805, these two little jumpers right here, and they just barely stick up slightly on one side of the board, or you can get to them from the bottom. And then this is a potentiometer right here, R806, and what it does is it varies the voltage output across these two terminals right here, if that makes sense to you. I'm going to jump over here to the unit and actually show you that. Okay, so we're back over here. It's kind of hard to see here, but you can look down in here, straight down. I've got one alligator clip, the red one, on jumper 805, and I've got the black one on jumper 804. And if you'll see down here, this white little potentiometer is 806 resistor, and that's what we're going to vary. And what we're going to vary it for is 35 volts DC here. So grab my little screwdriver, and I'm probably not going to get it better. I've already adjusted it, to be honest. But you could see when I first started, it was around 34.5 volts. But you basically turn this thing and get it up to 35, and they're a little temperamental. Matter of fact, the weight of the screwdriver on the potentiometer itself will vary it. See, I took the screwdriver off, and let's get back over here. It's about where I was before, 35.02. But I've also done something else here I wanted to show you real quick. If you'll notice, I've intersected this green jumper wire with the black, the ground. And I've intersected this yellow with the red here, just basically plug them in the cords into each other. The green then goes up to the oscilloscope ground, and the yellow, if you see it down here, I've actually connected my oscilloscope lead to it. And what I'm looking at here, let me show you this. So what we've got, I turned the light off, the light was causing a little bit of noise, but basically a flat DC signal here. Pretty darn solid, and what we've got riding on top of it up here is a 0.015 volt peak-to-peak AC signal, which basically implies this thing has little to no noise on it, and it's 35.02. But I like to look at that a lot of times, because if this little line up here was all squiggly or had a lot of noise on it, it would indicate to me that that the power supply wasn't putting out good clean AC, and that potentially these capacitors or something else in here needed to be replaced. But you've now seen how you set the voltage that will ultimately feed the output transistors on these two power output modules. You want to get that set right first. All right, so we've got the voltage set right. We adjusted it for 35 volts. The next thing we're going to do is we're going to connect to do the DC offset adjustment. Let me see if I can show you what that actually means. All right, let's talk about what DC offset is. So I'm feeding a 1 kilohertz sine wave into this unit coming from my function generator. And if you'll notice, this would be 0 volts right here. And so the sine wave goes up to a maximum, back down to 0, down to a negative number, back to 0, up, down, and it continues on and on and on. But here's what's key. This signal from here to here is centered and symmetrical around the 0 volt line here in the middle, right? So what DC offset is, let me show you this page. So if this was 0 volts and your sine wave was centered around it, symmetrical per se, but then you applied a voltage to the circuit that raised the overall, basically took the entire sine wave and shifted it upwards this amount of voltage. So let's just say this was 0 volts, this was 5 volts, and now all of a sudden your sine wave is centered not down here on the 0 axis, but up here on the 5 volt axis, and going up and down, so up to maybe 10 or 12 volts, back down to 5, down to 0, below that to maybe -2, back up to 5, if that makes sense. So you're offset one direction or the other by an amount of DC. Well, you wonder, well, why wouldn't that be an okay thing? You still got a sine wave, it's still nice and pure. Would still sound like a 1 kilohertz tone if you pulled the audio off the other side of this. Let me show you here in this picture. Similarly, 0 volts, except this time instead of a sine wave, it's a voice signal, and it's moving up and down, or whatnot. A couple reasons you do not want DC offset here like this. One, if your amplifier could only amplify 1 volt and you had half a volt of offset upwards, you would start clipping off this part of the waveform, but yet on this end having a full signal. So if you notice how these are getting clipped off, but you got full signal down here. So DC offset may cause you to start losing highs or lows on one end or the other, and it's just not a good thing. The other thing, have you ever plugged a set of speakers into an amp or a receiver, and when you turn the power button on, you hear a great big thump on your speakers? Well, what's happening is you're applying a DC voltage to your speakers, which is basically taking your cone that should be sitting center and moving in and out proportionally to what I would say, let's take a look at this. So if this was if your speaker cone was sitting here in the middle and you were playing music, as it would go up, in and out, speaker cone, in and out symmetrically, back and forth past a center spot. Well, if you apply a DC offset like this, all of a sudden your speaker, instead of being dead center, boom, it starts over here. So you're already halfway pushed out of your range that the speaker can move as well. So you're over in here. So now as your music starts to play, you're starting to slap up against the end limit on what the speaker can actually move because of this DC offset. It's probably not the most technical explanation, but hopefully it'll let you understand that this, the speaker cone should hover right there in the middle, around 0 volts, and as music plays back and forth, it should have free range to go back and forth. With DC offset on it, you've already started towards one end, and you're kind of slapping up against the wall per se. Well, let's take it back over. So what it says here is connect a DC voltmeter with a 0.5 or 1 volt range between the speaker terminals and adjust the trimming resistor R07 for 0 volts on the output. So remember what I was talking about, speaker? I mean, you're basically wanting to remove any DC voltage from the speaker outputs. So let's go show you how to do that. All right, let's look at what I've done here. I've came down here to the negative terminal of the speaker on the right hand side, and I've come over here to the positive terminal of the speaker on the right hand side, and I've clicked my 2 connections. And if you notice, I left the green and yellow wires intact, and I'll show you why here shortly. If you notice on the power output, okay, so right here, if you can read that, R707 right here. And this one happens to be, at the back here, R719. So, R707, we have a DC meter here, and I'm going to try to get it all within range so you can see it all at one time. Okay. 7.18 volts. Oh, excuse me, 71.8 millivolts. So let's adjust this output right here. 60/50 as we turn it. Oops. Tell you these things are touchy. Okay. 0. That's close enough. Even if it was 0.002. It's close enough. But now we have 0 volts DC on the output. All we have right now on the output, and the reason I left those other things connected, you can see we have a nice pretty sine wave, and it's not being shifted up or down by any amount. It's swinging equally off of the 0 point right now. All right, now let's go back over here and read how to do the other part while I've got all this hooked up. Now that we've completed the DC offset adjustments, let's go down here and set the idle current adjustment. So you're setting the amount of current flowing through the transistor at idle, in other words, not being driven. So to do that, let's do a couple things. First, let's connect and it says VTVM. That was just the flavor of the day back then. It would be a high-quality digital multimeter today. Between pins 708 and 710, and adjust the trimming resistor R719 so that the the digital multimeter reads 10 millivolts DC. So basically what you're setting is you're not actually measuring current, although that's what you're setting, but you're measuring a voltage across 2 points, which ends up yielding a current setting inside the transistor. And you'll repeat it for the other channel. But if you'll notice, this is very important to make sure that that there's no load connected when doing these adjustments. So let's go back over to the other side. All right, let's get a couple things done here. So first thing I've done is disconnected the speaker connections here. You'll notice the positive ones. And on this board, it's probably easier to see down here on this one, but R708, if you'll notice, it's on the positive side of this diode, and J710, I meant to say J708, J710. So it's on the negative side of this diode. So I'm actually going to go from that pin to this pin, and that's what I've done up here. Okay. Let's turn our voltmeter off. Let's turn it back on. And let's see what we end up with here. 4.7 millivolts, right? So we're going to come up here then. And we're going to start adjusting. Let me show you what I'm adjusting. Remember the first time it was this potentiometer. Now it's R719, which is this one. And I've just got my little screwdriver here in the middle, and I'm going to adjust it until I get 6, 7, 8, 9, 10, and as I start to pull this thing off. So finicky. I'm going to leave it right there, 10.03. That's about as close as I'm going to get it. Let's adjust the other side. Alright, one thing to show you, I was wrong a minute ago. When I said this alignment, during this alignment, no load should be connected, that was for the DC offset, which I had done. On the idle current adjust, I did have a load hooked up, just to tell you that. Alright, got the other side hooked up. Jumper, it's hard to read down in there, but 708. And on the other side, you barely see it there, but 710, you can see it connected. And we're sitting at 2.7 millivolts negative. Do you know why it's negative? That would be because I've got the leads backwards, and it really doesn't matter. It's just a polarity thing. It's still 2.7 millivolts. So come around over here to the other side. R719 on this one. Gonna adjust it. -2, -2.5, 6, 7, 3, 4, 5, 6, 7, 8, 9.9. I knew I couldn't get it to 2. Alright, we're going to leave it right there, 9.9 millivolts. And then what we've got to come back and do is check the idle current again. If you'll notice, it tells you to basically get it to 10 millivolts, which we did on both channels. Then it says check the DC offset alignment in procedure 2 again, and adjust the R707 for 0. So if you'll notice in 2 it was saying that there is no load. So let me show you. There again, I pulled the speaker wires out of the terminal. I've connected across the negative and positive. And I'm sitting here with -00.09 millivolts. We can try tweaking this just a hair here with R707 again. And we're at 1.2.0. Alright, that's about as close as we're going to get it right there. Let me move the leads over to the other side. Alright, we moved to the other side, and look, we've got 2.9 millivolts. So let's come back over here to our 707 on this side, and let's start adjusting it till we get to, we went negative. These things are very touchy. That's about as close as I'm going to get it, 1/10 of a millivolt. Should be pretty solid right there. That is how you bias a Marantz 2250B unit. Hang on, I'll show you one last thing. Alright, the last final thing I was going to show you, I'm going to grab the volume knob here. And I've connected this oscilloscope back across the output terminals again. And what I want to show you is this thing drives up. Nice clean sine wave. Stays clean, stays clean, stays clean, stays clean, stays clean. And if you'll notice, I'm pegged out over here. I'm driving it with a 1/2 volt or so, just about what line level should be. So nice clean amplifier. Very happy with the output signal here that I've got going. It's just a really nice clean sine wave. We're going to hook it up, do a little bit of distortion analysis. One day I'll make a video on that for you. And then we'll get this thing put back together for the customer. Everybody, I'd really like to thank you for watching our videos, and hopefully this video on how to bias a Marantz 2250B will be helpful, because it's pretty much the same procedure for a lot of Marantz units. I did do a how to balance a Marantz 1030, which is a slightly different procedure than this one. You can watch it as well. It was actually a restoration I did, and at the very end I showed you how to do a bias. So if you get a chance, check it out as well. If you notice, we've been sending a 1 kilohertz sine wave into this unit for all of our testing. It's a really nice unit. It's B&K Precision 4003 Basically, this side of the unit is a function generator with lots of different functions. This is a nice little attenuator knob that I use to adjust the input to be about a 1/2 volt into everything I'm feeding, which is basically line level. And then this half of the unit is basically a built-in frequency counter. Anyway, what I'm going to do is unplug this right here. Guess what this is? It's just a plain old jack that's going to come down here, plug into my MP3 player. All right, then all we got to do is find us some music. Let me turn that volume down a little bit. Alright, just a tad bit of scratchiness when I got all the way to the very right, and it wasn't distortion, it was scratchiness from the volume knob. I may try spraying it one more time with some deoxit, but for the most part, it's nice and smooth and clean. It's sounding really good. Really happy with how this unit turned out, and we're going to get it back to the customer. Thanks everybody for watching, and stay tuned for more.